All right, so this is lesson set 34, which we're going to do a little differently. I've been talking to a colleague who studies how students learn mathematics, what are the best ways, and he introduced me to a term yesterday called automaticity, right? Automatic comes from the word automatic, right? What's automaticity? 3 times 5, 15. That's automatic. You don't have to think about it. So if you were going to, use a multiplication and some other context, and that other context had higher level concepts, well, you don't want to get your brain stuck on what's 3 times 5. You want that to be automatic so you can give yourself the opportunity to think about the higher level concept. And that certainly comes into play in calculus. Now, you can't have these foundational problems, not knowing how to handle these problems, and then deal with, well, how do we find the area between two curves? These thin rectangles, where are they coming from? How do you create them mechanically and conceptually? What happens? And how do we apply these problems? So this stuff has to be automatic. And that's why we're doing so much repetition, right? Because that's how you learn your times tables. You get flashcards and, right? And some folks, unfortunately, still don't know them, which is, well, won't go there. All right. So I put a dot next to, I guess, 107 problems we've been doing. And everything I put a dot next to, I said, I would have done that mental math. This is just practice, right? We're not, in a soccer practice, you try to get your players to do something a little more challenging than what they're used to. They're always trying to push that needle forward. And it's no different in math. You want to push yourself a little bit. Well, here's your opportunity. Nobody's grading you. So try to do these problems in your head. And I put dots next to the ones that I would just write on an answer key, just looking. And I'll do that in a moment. I'll look at these problems and I'll put what I think are the right answers. And if I make a mistake, I make a mistake. It's just practice. All right. And then you learn from your mistakes. And hopefully the next time you don't make it again. All right. So try to get in that. And I hope, I don't get a lot of comments from some math teachers who think I'm, blasphemous right now. I'm not asking you to show your work. I'm asking you to think. Okay. And I think that's good for you. So it's much easier for me to solve a problem, an equation. Here, do I have an equation? Somewhere in here, well, here's an equation over here. It's much easier for me to follow your thought process if you don't keep writing what's on the left side, but the inverse operation's on the right. It's not hard. It's not rocket science. So let's get at it. Let's see if we can get a good practice session in. All right, so you're pausing the video. Try to do them all in your head. I don't think I would do this one in my head. I think I'd keep track of the numbers. Okay, so that doesn't have a dot. And we'll do that through most of the whole lesson set and have a little different type of practice experience. Okay, have at it. I'm going to have at it now myself. So I see that. I see 42. I see that. I see 43. I see 23 over 2, comma, 23 over 2 root 3, and 44. Oh, that's the wrong one. So that one should have gone up there. So that is now 43. And 44, I said I could do it in my head. Oh, yeah, you just write it out. So 4m minus 1 times 16m squared plus 4m plus 1. Okay, so those are the 5 that I think I would just put on an answer key and then move forward. All right, now I will explain what's going on because you're just learning it. You haven't been doing this for 30, 40, 50 years. So let's have at it. 2, 5 means I have e to the minus 3. This is asking for the exponential activity above e. Well, there it is. And you multiply. So I like that, no carelessness. Inverse operation is moving that to the other side. And I know what 1/6 to the negative 2 is. I flip it and square it. Boom, flip it and square it. So I like that one. No carelessness yet. 23, well, this is a 30, 60, 90. So that's half of that. And then this one is that side times root 3, which is approximately 1.73. If I double this one, that's a little bit bigger. A little bit bigger, multiplying that by 2 than multiplying that by root 3. And there's your difference of 2 cubes. Right? We've been doing tons of those. Let me get an eraser here. Okay, no matter who calls me right now, I'm not going to stop. I'm going to finish this video. I've already stopped twice and had to write this stuff down again. And I'm not doing that again. So we're gonna fly through this now. All right, so what do we have? We have critical numbers. I think that was a 2. I think that was a 1. I know this is a 1. So I have 3 critical numbers, positive 2, positive 10, and negative 2. And yes, the odds, I gave a dash. The evens, exponents, I gave a dot because there's not going to be sign changes. And I'll show you why there aren't sign changes as we go along here. So I pick a number bigger than 10. Bigger than 10 makes that positive. Bigger than 10 makes that positive. Bigger than 10 makes that positive. That quotient is bigger than 0, so that's true. That will be false. That will stay false. That will be true. Now, I know that's going to be a sign change because if I pick the number 8, 8 minus 10 becomes a negative. Whereas 2 times 8 minus 4 squared, still positive. 8 plus 2, still positive. So what's a positive times a negative divided by a positive? Well, that's less than 0, and I want greater than 0. You can do the other values, you know? You're capable of putting a number in and proving to yourself that that's a correct answer. And if it's wrong, I got Yasser to help me out. It's just practice, right? Just practice. Sound like Alden Iverson. Getting there. All right, so that's that. Now you got a whole nother set of problems. Try to do it mental math. All right, so you're pausing the video. Those are the problems. I'm not doing 46 mental math. I'm sure I'll lose track of those numbers with that many terms. But the others, I think I can just write the answer to. So let's see if I can. All right, write as a product. Well, 5's common. I need x squared. I'm assuming that's going to happen. I know 5 goes into 70 14 times from previous lesson sets. So that's a 7 and a 2, 7 times 2. And I believe I want a positive, so that's going to get the positive, that's going to get the negative, and I think that's right. But if I was going to give this to a colleague as an answer key, I'm going to write it out. I'm going to make sure. Some of these I'm not going to write out. I'm not going to write this one out. I'm going to flip it 4/9. I'm going to take the square root, 2/3. I'm going to cube it, 8/27. So that's 8 over 27. 45 is right there. In case somebody's moving that cursor all over the place. All right, this one here, I am going to take care of the x, y, z's first. So 4 goes in 7 times. 4 goes into 5 times. 4 goes in once. And therefore, there's a 4th root of, I didn't have room to put it here. So that's where we're at. I'll do 32 now, which is 16 times 2. I'll put it here because I'm showing 16 times 2. So I'm going to write 2. It's the 4th root of 16. There's a 2 here. And what are the remainders? 3, 2. Okay, so I probably just write that in the answer key. This one here. All right, so I'm looking at this and I'm saying 612 root 3. I'm looking at this one and I'm saying 2 times 4 minus 8 root 5. That's what I think that one is, you know, just for a handout. All right, and this one here, I'm going to subtract 2 minus 12 minus 3, 1 over 125, 3 and 1 over 125. So let's do it together. Let's take care of some space here. I think I can do that. I'll do this one out. So I'm seeing 48. I'm seeing 2 root 2 times 3 root 2 root 3. That's what I'm seeing. Okay, so root 2 times root 2 is 2. 2 times 3 is 6. So I like 2 times 6. I think I'm okay here. Now I'm going to do minus. Now I'm going to do 2 root 2 times minus 2. So I got to put a minus 2 there. Times root 2 root 5. Okay, first thing I'm going to do is get rid of the roots. That's 2. Times 2 is 4. Times 2 is 8 with a minus. I like minus 8 root 5. So I've checked it. It's correct. All right. Now let's go this way with this one. Let's go subtract 2. Divide by 4. Log base 5 on the other side becomes 5 to the, which is 1 over 125. And then I'm adding 3. And I'm getting 3 and 1 over 125. So the only one we have left now is this one. So let's get ourselves some columns. Minus 2 times 3 minus 6x root 5. Minus times a minus positive 4x4. Minus times a minus positive 2x cubed. I make more mistakes on this type of problem than most of the other work I do. It's tedious. Minus 4x to the 4th. Well, that's nice. I like that. Minus times a minus 8x cubed. Yeah, I got that. And I got minus 20x to the 5th. All right, so I got a couple of like terms. I got minus 26x to the 5th. And I've got 10x cubed. Okay, I'm hoping I'm not making careless errors, but if I do, it's just practice, And I'll find out, and then I'll learn from it. All right, so here's another batch. I didn't do 55 in my head. Right? I'm not gonna do 55 in my head. So I've gone through all of these and said, would I write anything other than the answer down? Only on this problem would I put pencil to paper. Okay, so you have at it. Come back when you want. I'm just gonna look and see if I can get answers. That makes sense. I'm seeing that. I'm seeing that. I'm seeing 11 years. I'm seeing the ln of 2 minus 2. And then I'll do that one out. Okay, we'll save that for later. All right, so now, oops, I got my ink cartridge over here on the floor. That's not going to do me any good in case the ink runs out of this marker. So 2 pi over 3. Again, if you're not able to do this, you need to look at the introduction to the unit circle video. I'm not going to give a lecture on that. It's 20 minutes, and I've already done it on the video. And it's been assigned. It's been assigned for a month. Circle. I'm right there. That's 2 pi over 3. I draw the perpendicular. That's 0, 0. That's the origin. That's minus 1/2. I like my answer. ln of 10/3. I'll do that together. All right, there's 2 ways to do it. There's one, e to the 0.7, e to the 1.6 over e to the 1.1. You're going to add these exponents and you're going to subtract that one, which means you could have also done it as the rules of exponents. ln of 2 plus ln of 3, ln of 5, excuse me, minus ln of 3. There's your rules of exponents, which we're trying to work through. And I'm hoping these numbers are so familiar to you that we have a little automaticity. See, repetition helps. I'm saying that better now. Yeah. And so there's your 0.7 plus 1.6. In my head, I had 2.3. And then I'm subtracting 1.1 and hoping I didn't make a mistake. I don't think I did. All right, so that's how I'm doing that. I'm hoping you will do it that way at some point. All right, PE to the RT, compound interest. We're going to dive into that more in a month's time. Okay, but right now we're just getting the mechanics done. So we're trying to triple our money. That's what we put in, $100 usually. If we triple it, it will come out as 300. E to the 10% is 0.1 T. If we want tripling, I want 1.1, just for the record. So I'm dividing by 100. There's 3. There's e to the 0.1 T. Okay, there's your ln of 3 equals 0.1 T. So I have 1.1 divided by 0.1. I guess I got to go higher here. 0.1 into 1.1. And I think that goes to 11 times. So 11 years. It's a good interest rate. You get that interest rate anywhere, take it. All right. 1/4 means the 4th root. That's where 1/4 times the exponent on top of e is coming from. So I could have moved that here. And 1/4 means fourth root. And the fourth root of 16 is 2. That's how I got ln of 2. And here I'm asking for what exponent on top of e gives me e squared. Well, that's a 2. Those are inverse operations. So I like waiting for that moment when I make that careless error, but I don't think I've made it yet. It'll come, and I'll learn from it. So you got to learn from your mistakes. I wish I had known that earlier in life. X equals -2 means that x plus 2 is a factor of, I'll just leave that there so I can look at it and say, oh, x times x squared is x cubed. 2x squared. I need minus 2x squared. So minus 4x times x gives me minus 4x squared. 2 times minus 4x is minus 8x. I need another minus 5x. Well, there it is. And I like that because that's x plus 2 times x minus 5 times x plus 1. So what are the roots? The roots are -2 and -5. I'm doing this for a reason. +5, excuse me, 2 and 5. And I got to put this one -1. Let's add those up and divide by 3. -3 plus 5 is 2/3. Oh, let's take this and change the sign and divide by 3 times a. Oh, 2/3. Must be a strange coincidence. That the point of inflection, the x value of the point of inflection, is the average of the roots. Go look at the completing the cube video and you'll see geometrically why. Okay, and it won't just be a mechanical problem anymore. You'll actually have a little conceptual awareness. But it takes a little effort. But I strongly suggest you do because it explains things. It's called completing the cube. Okay. Did I miss any problems? No, we're moving on. All right, so I didn't do 58 and 61. I said, you know what? I'm probably going to make a careless error there. I'm not going to trust my work. So you pause the video, you know the drill, YKTD. I'm just going to look at them and put my answers over there. I think that's -5√3. The domain for this is x has to be bigger than 0, but x cannot equal 1. We'll talk about these. Average rate of change. Yeah, I'll make a mistake, but I'll still try it. I'll go 16 minus 4 is 12 divided by 2, 6 to 1. Actually, by doing it that way this time, that seemed pretty, not too bad. So that one there, 1/√3 occurs at pi/6 and 7 pi/6, I believe. Number 60. Well, we're just going to write it here. So we have 2x to the 7th. Did I leave enough room? Probably not. So I could write this as a product. 2x to the 7th, that's the cube root of that, minus 5y, that's the cube root of that. The second parentheses gets built off of this. I have to square that. That's 1 dimension. I need 3 for a cube. So I got to square this, get the other 2 dimensions. 4x to the 14, I'll write small. Plus 10, I got to get some cancellation here of terms. 10x7y plus 25y squared. I think you can see that. We've done enough of those. You should have followed that. All right, 61. Can I do it in my head? We'll try. So that's 5/3. Goes through at 1. No, I got no idea if there's even a solution to this. 5/3 is to the right of 1. That's the x-intercept. I don't think these things have a solution. Well, let's find out. So 3x minus 5 equals x squared minus 2x plus 1. So therefore, 0 equals x squared minus 5x plus 6. Well, -2 and -3. So it did. Oh, that's because this is going up so quickly. So what made me think that 5/3 is here, the x-intercept for that is 1, which is about here. And so that's doing that. But this went up so quickly that it intersected at 2 and it intersected at 3. I'm not drawn to scale here, but I am trying to explain what happened. All right, so we plug in a 2, square root of 1 equals 1. That's true. We plug in a 3, square root of 4. equals 2. Yes, did have intersections, but this threw me off. I learned something, okay? And I pushed my brain a little bit to picture the graphs. All right, and now next time I'll look at this and I'll go, oh, that's going up 3 times as fast as the normal one. That's what I initially thought. Yes, so that makes perfect sense. Okay, that's the learning process as we speak. The limit of, as we go to infinity, is gonna, the little guys don't matter when we put 1 billion in here. It's just that. And what is 2x divided by x squared? Well, that's 2 over x. And as this number gets bigger and bigger and bigger and bigger, this fraction gets smaller and smaller and smaller and heads toward 0. Okay, did I miss any problems? I did. Oh, I haven't explained this one. So we've been talking about the 30, 60, 90 as being √3 over 2, 1/2, and 1. Well, I'm just doubling the size of it, which means that this then becomes 1, this becomes √3, and that becomes 2. And I'm looking for the tangent. And so the tangent of this is 1 over √3, and I can see that here. If I move the 1 over and divide by √3, I can see that. So a positive divided by a positive. So let's cut to the chase here. I'm over here for that one. I could have also had this one, because that's a negative divided by a negative. So I could have also had that. This is 6 pi over 6, right? You're breaking this up into 6 parts. There's good drawings, get good answers. And the negative divided by the negative, going to be a solution for that. Average rate of change from 2 to 4. Well, I got to really extend the parabola here so you can see that a 2 gets us a 4 and a 4 gets us a 16. And all I'm doing is finding the slope between those, and I'll let you do that for yourself. 16 minus 4 is 12, divided by 2, 6 to 1 is a good answer. I've got 2 restrictions on domain here. One is division. I can't divide by 0. Well, guess what the L on a 1 is? It's 0, so I can't use a 1, and I have to have positive numbers in the parentheses. So x has to be bigger than 0, and it can't equal 1. Did I do the tan of 5 pi? I probably should have done that one first. So 5 pi over 3, if I'm doing chunks of 3, there they are, 1, 2, 3, then there's 6 here, right? That's the 5th one. So what do I have? I have negative √3, and I have 1, if the hypotenuse is 2. So negative √3 divided by 1 is negative √3, times 5 is minus 5 √3. Okay, so far so good. I'm going to get tired. I know I'm going to get tired. I'm pushing myself, especially since I had to start over again because of a phone call. All right. And I don't know if that will happen again. There is one call I have to take, but maybe I won't. All right. So what do we have? Everything but that one. Although that's such a familiar problem to me. No, it isn't. Probably have to do it out. We'll see. All right, because usually there's a 3 here. So I've made it a 2, which means that I might be playing with you here a little bit. I don't know. We'll get to it. So piecewise, we've in the last lesson sets looked at the fact that my slopes are 15 and negative 15. And it's a V shape up. So I'm going down at 15 to 1, and then I'm going up at 15 to 1. We proved that with the y-intercept numerous times. So I think go to an earlier lesson set. So what do we have? We got Alfred Hitchcock. It's a strange Alfred Hitchcock today. So I'm going down at 15 on this one. I'm going up at 15 on this one. Where's the hinge? At x equals 1. So x minus 1, x minus 1. That's where the hinge is. And I get a 1 out of that. So when x is less than 1, I'm decreasing because this is where the vertex is. It's at 1, 1, 1. It's at 1, 1. So a lot of people make mistakes here, and I don't see how you can on this one. You're really looking there. That's where I'm getting this 1. Okay, and x greater than or equal to 1. All right, so that takes care of the piecewise. Oh, I was going to do these in my head. Oh, all right, well, kind of. So this one here, 67, let's get rid of that one quickly. Right, I'm hoping you see a binomial square. Hoping you see 3a minus 5 squared. That's just a recognition. You think about this one for a second. It's going to 0. just 1 over x. Okay, if x is 2, 1 over 2. If x is -4, 1 over -4, which is -1/4. So that was a recognition. 66. Oh, I do these in my head. All right, so I got to do it in my head. Maybe I wouldn't. I don't know. I'm going to put it here. In my mind's eye, this 46 is going to be right there on this side of the equal sign. Then I'm going to do the math. 46, so 45, 9, 12, 3. So I now know that I intersect the height of 46 when I put in a 3. All right. Now what's 3 times 15? 45 plus 1. Okay, so I hope you can see that. I think I made a mistake here. This is my first mistake, I think. So let's find it. So subtract 1 from 46. 45 divided by 5 is 45 divided by 5 is 9. Plus 3 is 12. Divided by 3 is 4. Aha. It's a good thing I did that. Okay, now if you plug in 4, you get 9. Okay, I thought I made a mistake there. Okay, I'm not quite sure why my brain went, oh, mistake, but it did. All right, so now how, maybe it's because it's 3 units. 3 units from 4. Maybe that's what my brain was doing. So that means the other side, I'm going back 3 units now because of symmetry. There's no reason to solve for -46. Right? There's no reason to do that. By putting -5 here. Okay. So -2 gets me 46. So you can check it. -6 minus 3 is -9. The magnitude is 9 times 5 plus 1. Okay, so we're good with these numbers. Now, when am I greater than 46? I can see when I'm bigger than 46 for these y values. Those y values are bigger than 46. When does that happen? -infinity to -2. And did I want or equal to? Or equal to, so that's a bracket. Okay, union 4 to infinity. Okay. Now, even if you're getting that wrong, the first stage of learning is following. All right. And if you're not following, you just got to keep looking at it again, but only a couple of minutes a day. And if you keep doing that, usually by day 4, you've got yourself something done. And if you do that with 107 problems, 4 days in a row, well, imagine where you might be. How many of those can you nail? It's probably not 107. I mean, that would be asking a lot. The most I've ever seen somebody do in 2 days was 40 problems. Student got 4 right out of 50 questions on a test, and 2 days later got 44. Somebody spent some time looking at the material in 2 days. That's a heck of an improvement. That young man's going into engineering now. After the first test, which was a pre-calculus test on these worksheets, getting 4 right. Got to wonder, okay, where's the educational system? He's a bright young fella, but equation of a line, factoring, all the things we've done in those early 40 problems that I'm not even asking you to do anymore, except on your own. So yeah, you can learn a lot in a short period of time if you just kind of do the flashcard system. Get a problem, not sure what it is, look at it, give it a few minutes, 10, 20, 30 seconds of thought, put it in your pocket, pull it out again 6 hours later, boom, boom. You might already put something in the old noggin. Talking a lot here, making a big mess. All right, so we did that. We did this. We did this. We did this. We did this piecewise. Okay, we got that last problem to do up here. Got my frame of reference now. All right, so quantities multiplied give us the exponential activity. So that's x squared minus 2x minus 8 equals what? 2 to the 2, which is 4. So now I've got x squared minus 2x minus 12 equals 0. I can't think of 2 numbers that multiply out to be 12 that are 2 apart. So I'm going to have to do x minus 1 squared minus 1 minus 12 equals 0. And therefore, I've got 13. I've got plus minus the square root of 13 plus 1. Now, 1 minus the square root of 13 is certainly smaller. It is a more negative number than -2. If it's more than -2, then I can't do the negative because it breaks the domain restriction on that term. It certainly breaks it over here. right? I wonder if there's 1 plus root 13. Root 13 is less than root 16, which is 4, but it's bigger than root 9, which is 3. So it would be okay here. All right, so I'm assuming that's a correct answer. And if it's not, somebody write to me. Hopefully Yasser's still brushing up on his algebra. All right, it's good practice, especially for us older fellas. I'm doing this partially because I'm in the midst of cognitive decline and I'm trying to slow it down a little bit. All right, so, okay, so you just write your answer for that one. Yes, this, all 4. I think you can do all 4. Just write your answers. So you try. All right, what have I got here? I've got minus x squared. I can see if I square that. That gives me 8. 8 minus 8 is 0. That's minus x squared plus 8. And I can see that 0, 8 means I could have done this, right? Because that's the vertex. And then I drop in the square root of 8 and go, oh, that works. So that's how I did that one. This one here goes through 0, 0. So down 12 over 6. So that's negative 2x. Okay. That's an equation, which I could solve. And then you could nail the coordinates of the intersection. All right, so what's the inverse of this? You can just write that answer, I hope. The inverse of this gets us y values, so 3 to the y, and then you're going to change it to an x, which means those outputs become your inputs in this problem, plus 4. And that's the inverse of that. This one here, you try it. Let me do it out in my head. Minus 2, 3, so it's got a division by 5. Minus 6 becomes positive 6. I think it's 6/5. Let's find out right now. 1/4 to the x is 2 to the minus 2x. 8 is 2 to the 3, x minus 2. So in my head, I said minus 2x is going to go over to the other side with 3x to make 5x. And 3 times minus 2 is negative 6. I'm going to bring it to that side. I like my answer, 5, 6. All right, remember, it's just practice. All right, E notation. Well, let's get rid of that. Let's get rid of that. I know 1/3 is e to the minus 1.1, so I can put minus 1.1 there. And dividing by 1,000 is 3 zeros, so 1, 2, 3 decimal places to the left with a dot. And there is the same function written in approximated E notation. All right, we did them all. Just practice. Would I commit that to paper? X plus 3, negative 3. Doesn't say or equal to, so no, I think this is just greater than 2/5. So I think x is greater than 2 over 5. Tangent of that's 0. This one here, 49 minus 4, 45. 45, can't really write that. 45 plus, what was it? 1428i, I think. All right, that's that one. Right, it's a product. 1/5 plus 1/2 times 1/5 minus 1/2. That's that. This one here, 16, 8, e to the 8 plus 5. All right, so we'll check those answers now and see if they're right. So this one here has, at 2/5, I already made a mistake here. 2/5 is bigger than negative 3. I was getting numbers bigger than 3 in my head. So there's my first careless error. Minus 3, and this is up. No, I think I'm okay. Because I'm talking to you now. Minus 3, 2/5, I think I'm okay. All right, and so that's got, no, I'm not okay because that is sign change there. So this is less than 0, I'm way off. So it's when x is less than negative 3. So there's a careless error. And so what do I do now? I think about what I made a mistake. You know, and I look at that and I was like, can I do this? It was a little awkward for me. Do I want to do that? No, that was what happened. It was a little bit too much at this stage for the brain to handle. But good learning moment. Okay, so less than, so if we do it with a sign chart, a lot of people do this for quite a while, 2/5. right? There's no sign change. If I put 1,000,000 in, I'm bigger, true, no sign change, true, false, right? And so I wanted, oh wait, I want less than 0. Less than 0, false, 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 true. There we go. Yep. Okay, so less than -3, I think is right. All right. Tangent of pi. Tangent of pi, sine divided by cosine, you'll find that out. That's the sine function, opposite side divided by the cosine function in the unit circle. And pi is over here. Sine measures the heights of the triangles drawn. There is no height. There is width of -1. And the hypotenuse is 1. 0 divided by -1. Okay, I can stand by that. All right, so factoring this, 49 plus 28i plus 4i squared. Just had to deal with that. Take 4 away from 49 and write your answer. Difference of 2 squares. Hopefully that looks good. Let's see if I get this answer. Subtract 7, 16, divide by 2, 8. The inverse of ln is e to the. So what is that number? Well, it's less than 3 times 3 times 3, 8 times, and it's bigger than 2 times 2 times 2, 8 times. It's approximately 2.71 times itself 8 times. Well, times itself would be 7 times. That would make 8. There you go. Somebody's calling me. Figures. I'm not even going to look at it. I'll call back later. I got a feeling I'm supposed to look at it, but I can't. Yeah. All right. No, not going to look at it. I'll just see who it was later. All right. It's gonna be a long video. All right, can you write that one down? Yeah, I said so. So everything but this problem, I think you probably can just write your answers for. Okay, so have at it. I'll just do the answers now. 78. So let me do this. Let me put 78, 79, 80, 81, 82, 83. All right, so I don't think I'll do that one in my head. The others I'll do in my head. All right, so x squared minus 18x, 81 and 25, 106 equals 0. I think that's what that one is. I'm not doing that one. The equation, I'm just going to solve an equation. I usually ask roots, but I'm asking you to find out when this quadratic hits minus 100. Okay, and I'll just give you the answer. I'm measuring from 5, I'm going from 7, so plus minus the square root of 107 divided by 2. We'll do that out in a moment. 81, point of inflection. Well, I can see that -1 is the number I got to plug in here. So that's going to be -3 double, -6 plus 10, 4 plus 5 is 9. I think that's the point of inflection. If I'm wrong, I'll find out. Y-intercept for number 82. I probably should have given you some directions there. So if you didn't do that because you didn't know what to do with it, do so now. Y-intercept. So I'm looking at minus 54 plus 7 minus 54 plus 7 is 47, -47. So I think that's that. 83, what are the coordinates of intersection? Geez, that's, I'm not sure. Not sure if so x squared plus x minus 20 plus x. So therefore it's x plus 5 times x minus 4, so -5. -5 squared is 25. I think -5, 25. I'm just practicing. And positive 4, 16. Well, that looks good. Because -4 plus 20 is 16. So I like that. And -5 squared, 25, minus and minus 5. Yeah, so those are the points of intersection. Now we'll do the problems out. So what did I do here? I did x minus 9 equals plus or minus. They come in pairs, although this was probably written a long time ago or I didn't know where to find plus minus symbol. So therefore this becomes x squared minus 18x plus 81 equals 25i squared. Oh, did I make a mistake? Oh, negative. No, positive 25. Yes, so that becomes -25. When I bring it over, I get 101 plus 5, 106. So yeah, that was fine. This one I would not have done in my old head. Too many things to remember, especially when the brain gets tired. So we got 5, root 4, root 5, plus 3, root 9, root 2, minus 2, root 9, root 5. So it looks like I got some root 5s here. So let's take care of those right now. That's 10 root 5 minus 6 root 5 is 4 root 5. And that's 6 root 2. And these are like common denominators. They're not common. They're not common radicals, so I can't count them. Got to leave it as is. All right, so let's get rid of that. So that's gone. This one we didn't do it out. I just gave you the answer. All right, if you got that, then you've got the graphing form right now. I mean, that gives you that. And we're setting it to negative 100. So what do we have? We got minus 107 divided by negative 2. I'm going to do it here. Plus minus square root. Add 5. There it is. That's done. All right. So now, point of inflection. Did I do the point of inflection? Yeah, I did. Let's find out if I was right. Minus b, minus 9 over 3 times a. Okay, so far so good. Minus 1 is right. If I put minus 1 in here, I get minus 3. I should get positive 9 here. I do. Minus times a minus is plus 10, plus 6. I don't like that answer. Maybe it's right. 19, no. So this was wrong. I made a careless mental math error. So this is positive 6. I remember now I said negative 6. Right? I didn't change the sign in my mind's eye. Now I know where I made my mistake. I'll be careful. I'll be more careful the next time. So I got 6, 12, 22. So that should have been a 22. Okay, careless error. But good practice. Put a 0 in. Minus 27 times 2, minus 54. I remember doing that. 0 takes care of that, plus 7. And I hope that's minus 47. Yes, that's okay. This one here, x squared equals minus x plus 20. So in my head, I brought those over to the other side. And I knew that I needed a positive, so I knew it would be x plus 5 times x minus 4. And so I took negative 5, I ran it through, and I took 4 and ran it through and hoped I was right. And it looks good. All right. X-intercepts. I'm not going to do that mental math. 2x plus 3. At this stage, I don't know. All right, let's try that one. All right. And then this one, no problem. This one, no problem. No problem. Okay, so those 3. Oh, see, I already did dots here. Yeah, and I was saying, do I want to try that one? I wasn't sure. Okay, definitely not this. I got to do that one out. Okay, and I think we already did that one actually. But maybe I didn't ask it in that context. All right, so 2x plus 3. So this is no problem because I'm just doing f of x. So that's 2x plus 3. So getting rid of that means that I'm just plugging this into the doubling and adding 3. So 2x plus 3, right? So 4x plus 9. That's the answer to that problem. This one here, subtraction of exponents means division of those quantities multiplied together. So this is simply the ln of 17 over 70. 7 times 10. Maybe I should write it that way. Okay, using the rules of logarithms. What's the period? 2 pi over 3. That's the period. So where am I starting from? 3x equals 0, add 0. Sine function. Where am I finishing? When 3x equals 2 pi. Oh, yes. 2 pi over 3. Approximately what? 1.04 radius lengths. So about 1.04 here. We've got something that's going up 5 and down 5. From a height of 11. Might as well get the whole graph, right? All right, so that's that one. We've been doing these since the first week of class. X minus 7 plus 3, 7 to 15, square root of 8, 3 to negative 9, down 12. All right, so that's just practice. All right, now we're going to do the graphs. There's not much you can do with those except write your answer. So you have at it. All right, and I'll just tell you what things are. I'm going to make this into, I'm going to use a sine function. So if you did it with a cosine, that's fine. But I'm going to do it as a sine function because I want to highlight that we're changing years into angles, and that's a linear, right? So I want 1507 to act like 3 pi over 2. So x minus 1507, I want to act like 3 pi over 2. Why do I want it to act like 3 pi over 2? Because what's the sine value there? Negative 1. That puts me at a minimum. All right, so I got my minimum. 1507 to 1600 is 93 years. And what happens? 1 pi, 2 pi, 3 pi. 1.5 revolutions. 93 years, it's a sine function. I'm going up and down from the center. Oh, I never gave you a value over here. I'm sorry, you couldn't have done it. How about negative 40 to 0? All right, so we're going up to the x-axis. All right, so what am I measuring from? I'm measuring from the middle line of, let's not make it that because it's going to be similar. Let's make it go up to negative 10. All right, so then that becomes minus 10. Right, and how far is it from minus 10 to minus 40? 30 units. And I don't put a negative in front of that because I want to be at a minimum. So I want this to be, when I put in 1507, I get negative 1. Negative 30 minus 10 gives me what I need. Okay, and then I gave you another sine function. No, I don't usually do that. Okay, not sure why, but let's double up on it anyway. So you try it now. We're starting in the middle. So I want 1700 to act like the middle, which is not traveling at all around the circle. Positive sine function, 10, 50, plus 10 is 60. So therefore I am baseline 30. All right, I'm measuring from 30. From 30, I'm going up 20. I'm making it a sine function. Now I just got to get the period of this from 1700 to 1804, which is 104 years. 104 years, if I'm not making a mistake. And it's 1 pi, 2, 3, 4, 5, 6, 7.5. So 7.5 pi. I'll write it here. Okay, so 3.5 revolutions. I'll do 1 revolution, 2 revolutions, 3 revolutions. Ooh, 4 revolutions. Woohoo, made a mistake. 4.5. 4.5 revolutions is 9.5. 8.5. Ooh, boy, am I getting tired. There, I think I got it right now. Somebody can write to me if I'm wrong. All right, so see if you can play with this one. I'm having a little fun with you here. All right, that's just a continuation of the sign change, sine function in that direction. We're actually going in the other direction. It's just a reflection. It's an odd function. Haven't heard that before, where f of x equals minus f of minus x. Let's just prove if that's true. Put in minus 2 pi. What is the sine of 2 pi? The same thing as the sine as minus 2 pi. And I'm doing the opposite of that. I didn't explain that too well with that particular value, but it's a little exposure to something we'll talk about more later. At this stage, I want to finish up because I'm running out of gas. I've been at this since 6 o'clock this morning, writing these worksheets and doing this, and it is now almost 11. So I've been working a lot today. Y equals 1 over x. Well, from earlier problems, I hope you know that that's this. That's 1 over x. 1 divided by 5. If x is 5, I get 1/5. If x is 1/5, I get 5. All right, so hopefully you just get some recognition here. Sketching that one. Okay, I'm going to just go with this here. Phew, I hope this keeps recording. All right, so I have V-shaped down, vertex 3, 7. Throw a 0 in. 3, -12 plus 7, -5. How do you get from -5 to 7? You go up 12. How do you get from 0 to 3? You go up 3 units, and there's your slope. +4 on the left, -4 on the right. Doesn't hurt you to hear that again. All right, so let's get rid of that, make some more room for the rational function. What do I see? I see an x-intercept at 0. This is going to go through the origin. I see that it heads to 0 because the big players are x over 2x squared, and that reduces to 1 over 2x. And as x gets bigger, my fractions get smaller, both sides. Y equals 0. X equals 0 is an asymptote. No, I don't have that yet. Forget I said that. 2x squared equals 8. I want that to equal 0. So that's +2 and -2. So over here at x equals 2 and x equals -2. And to make sure I'm not saying something stupid at this stage, 2 squared 4 times 2. Yes, those numbers are right. Got to check things now because I can feel myself headed towards carelessness. All right, so I definitely have no more x-intercepts. So it's positive on the right. It's negative on the left. I get sign changes because I could write that. 3 sign changes. So I'm going to go from positive to negative to positive to negative. So it's got to look like that. Let's check it to make sure. Let's put a number like -1 in and see if we get a positive answer. If not, got to think about this some more. -1 in the numerator, -1/6 in the denominator. So it's really doing lower and then up is what it's doing. Okay, lower and then up. So that would give it a little better trajectory. All right, so that's that. Did I ask any questions about that one? Limits? I usually do ask about limits. So maybe I didn't write those down. I don't know. But what's the limit as x goes to infinity? As g of x, was this g of x? As g of x goes to infinity, I hope you say 0. What's the limit as x goes to 2 from the left? From the left, I hope you say -infinity. Okay. When is this thing bigger than 0? Well, I hope you say, from -2 to 0. All right, these are positive y values, and so are these. So I'm hoping you say union 2 to infinity. All right, I didn't write those down, but I usually ask those questions. So why I didn't, I don't know. Maybe I did it elsewhere and forgot to write them down, but we want to consider them. Almost done here. Thank God. All right, this is a logarithm. X's have to be bigger than 0. If I put in a 1, I get a 2. If I put in a 5, I get a 5. Trying to speed up. Okay, go to earlier lesson sets or go to the playlist, logs and exponents. How do you graph them? All right, next one. I'm assuming you've done earlier lesson sets. So I have a 5 here. My first jump is 12, so I'm going up to 17. And my next jump is to 9. So let's get 17 higher. Let's get 9 here. Okay, so I've got the dots. Let's put the dots here. All right, so let's do that. Let's do that. So what number do I pick? 2. What number do I pick? 3. Okay, that's that graph. Okay. Modern technology, spend more time with it. All right, so this is a 1/5 is the multiplier into 2 pi, which means 10 pi. I'm going to start from 0 and I'm going to end at 10 pi. The end of the revolution, go Che. What's 10 pi divided by 5? The end of the revolution, it's a positive, so boopity boopity. Okay, and going up and down 4. So we have a maximum of 4 and a minimum of, 4 plus 3, excuse me. 4 plus 3, a maximum of 7. I didn't look at this, I should have. So I'm up to point of 7 and I'm down 4 units from 3, -1. So my range is -1 to 7. That's been a test question. All right. -1 to 7. There's your range. And everything else is symmetric now. 10 pi gets me 3. So 5 pi gets me 3. 0 gets me 3. So on and so forth. In the period, 10 pi. Okay. How do I write 5 minus 2 as a difference of 2 cubes? So 5 is the volume. 5 is the volume. So the cube root of 5 is the first dimension. So I could write this 2 different ways. I'll write it the way I started. I've got the cube root of 5 minus the cube root of 2 times the cube root of 5 squared. I got to get some room. Yeah, I put these things on the board a long time ago. Where am I? I've got to get this product and change the sign. So it's just a positive root 5 times root 2, which could have been written as the cube root of 5 times 2, which could have been written as cube root of 10 plus the cube root of 4. 2 times 4 is 8. And the cube root of 8 is 2. All right, boy. Oh, boy. A lot of practice today. A lot of practice. But you know, that practice is going to come into play in future classes where you're not going to work so hard. You're going to make up a lot of time in other classes, especially if you go into STEM. So I'm hoping that you stick with these as worksheets that will allow you to go up the ladder. All right, stay safe, stay warm.